Sir, one question is there. The gravity value acceleration that we have inserted means load with respect to gravity value. It is for its own weight, or it is something. It is not for its own weight.
1 minute. So in case of all this, right, 1 minute I'm coming, you go to force, insert. These three, acceleration, standard gravity and rotational value, these are the inertial load, okay?
Okay.
That means in for these three, your density is required, okay? The density, it will calculate its own load, and your load will be applied as per its own load, okay?
Okay.
You can give two, as for example, in case of your that competition vehicles, Baja, Supra, Baja, Supra, etc. All this, we give 2G, 3G, 4G, 5G type of load, okay? Or crash loads, okay?
Okay.
In the horizontal direction. So it will take its own weight.
It will take its own weight. Yes.
Yeah.
Okay.
Now, force. Force we are applying here.
Hmm.
We have given that component. Oops, 10. 10 is too much. Okay, let us keep it 10. Now here your some fixed support was given. So we change that. Okay. Fixed support is only on this face. Here we remove from here. I have removed from here. Okay. Apply. So fixed support. Let us delete the fixed support. Delete. Okay. Yes. Now apply the fixed support in this face only.
Okay. Now it is a cantilever type.
Insert fixed support. Yeah. Yeah. Apply. So fixed support is only in this side, and your load.
Load in the other side. Yep.
Fixed support. One fixed support is come here. Delete. I delete it. So fixed support is in this side. So load is we will give in this side. Now load. Insert. We are giving force. Force on this edge.
Yeah.
Select the edge selection filter. This edge. Apply. And change it to component. And give a minus z value. In minus z, say 5 Newton or anything you give, okay, for test purpose. So this is our model, okay. Now solve.
Okay.
What happened? Fixed support has come on both the ends. Okay. Control I select this.
I think it is still selecting the both edges.
Apply. This. I delete this. Let me delete it and then give it. Okay. Insert fixed support. Go to surface selection. This one. Select this. Apply. So only one face is there. Okay. No problem.
Yes.
Now it will do. Because it already. Solve. Okay, it has come. Okay. So force we can apply on your on body, on surface, on your edge, on vertex. Okay.
Okay.
Now suppose our requirement is to apply some force here in between.
So
Okay, so how will apply?
Yeah.
How we'll
So
apply.
can we how to select the reaction force on the sub point? Means
Here.
here
So
the
it is clear.
reaction.
Okay.
Okay.
Force reaction.
Force reaction. Okay, sir.
That will come. Okay.
Hmm.
You go to flow, force reaction is there, so it will come over here. Now, say I want to apply some load in between, not here.
Yeah.
As the edge, in between I have to apply some load at some specific location. How to do that? Let us see. Okay.
Okay, sir.
Have you understood the your question?
Yes, sir. It's
So we
clear.
have to apply some load
Hmm.
in between some specific location. How to do that?
Yeah.
So there can be in two ways. Okay.
Hmm.
The best way is again to go to design modeler. Design modeler. You have to come to design modeler here. Now create points are there. Okay.
Okay, sir.
If you call your model from outside, for example, CATIA, CREO or SolidWorks or whatever it is, you have to
Hmm.
come here. You have to create
Hmm.
point over here. Okay. Point.
Okay. Hmm.
Point. Now point type is spot OLED showing. Change it to point load.
Point load. Okay.
Defined by sequence of n. Now base phase. Base phase on which phase we want to create point. Let us see. Let us assume this one. This was the base phase. Okay. Apply. Now guide edge. Guide edge. I select this as the guide edge. Apply. Now offset. Edge offset.
Hmm.
Edge
Sir,
offset.
the concept of base phase and guide edge, it is not clear to me.
Uh,
Base phase
let,
means
let,
where we.
let me
Okay,
first say it and then we ask. First,
okay,
let me
okay,
complete it.
okay,
Age offset. Age offset. I say. I will create at a distance of 50 millimeter from here. Okay.
okay.
Age offset 50 millimeter. Number of points. I create
One.
say 4 points. Okay.
Okay.
Now generate. It has created 4 point. Hmm?
Hmm.
Now I want to apply force on these 4 points. Okay. We never apply
Hmm.
force on a single point. If we apply force on a single point, then there is a chance of stress concentration on that point. So always
Hmm.
select more than 1 point to apply the force. Okay. So I will apply the force on
Okay.
these 4 points.
Okay. Okay, sir.
So this is an important one to get the your points where we will apply the load. Okay.
Hmm.
Another option is you can split the your component here at the location where we no, want to apply the load. You split
Hmm.
the component. Okay.
Okay. And then apply the load on the edge.
On the split edge. Okay.
Okay.
Now we will use these points. Again, go to this your okay. You give so vertex.
Hmm.
So it is not showing those points. Okay. So have I done the generate? I have given the generate command point. Okay. Now this is this. So what it is? Let us see. Yes. Remesh it. Clear.
Hmm. Hmm.
Then go to project page, update project. You give an update project.
Yeah.
The point,
Because we have.
it show the point over there. Okay, it's not showing.
Hmm. Hmm.
So tick mark has come. That means it has successfully updated. Now go to your this one. Now it is showing the point. Okay,
Hmm.
the vertex it is showing.
Hmm. Hmm.
Now when you will mesh it, it will give some message. You see, it was earlier it was a your hexa mesh. Okay, now it
Yeah.
has changed to your this type of mesh. Okay, that means
Random.
tetrahedral mesh.
Random. Hmm. Hmm.
Default tetrahedral mesh it has created because of those points only. Okay.
I see.
Now, if I want to change the mesh, let me try. Okay. So go to mesh, insert your method.
Method.
Geometry is this. You select the whole geometry,
Hmm.
apply.
Hmm.
Now change from automatic to hex dominant.
X dominant.
Then
Okay.
update mesh. Let us see what happens. Hex dominant. It has not created. No, it has created. Okay. Now it has created like this.
Yes.
Mesh
Yes.
will not come as it was showing earlier. Okay.
Yes.
That type of mesh will not come. If you want the mesh
Hmm.
only, if your main interest is to your show the mesh in a nice way, then what
Hmm.
you have to do, you have to instead of point, you split over here. Okay.
Yes. Yes.
In
Hmm.
case of split, the mesh will be as per as you have done earlier. Okay.
Hmm.
But when
Hmm.
you have created the point, the mesh will pass through the point. One node will be
Yeah.
there on the point. Okay.
Okay.
So in that case, it has the mesh, your mesh, that fine type of mesh, it has been disturbed. Okay.
Hmm.
Now the
Okay.
mesh is coming in this way. So you have to
Hmm.
accept it.
Hmm.
Now force. I delete the force. Okay.
Hmm.
Now I apply the your force on the nodes on the your vertex. Okay.
Vertex points. Okay.
So what you can do, you select the vertex. Here only 4 points are there. Now,
Hmm.
if so many points are there, so you have to what you have to do? You have to go to name selections. Select
Okay.
all the vertex. Wherever you will give the load, create a name selection. Okay, give the name.
Okay.
I give load point. Load points. Okay.
Hmm.
So now insert force force. Yeah, it is showing geometric selection. I changed to name selection. Name selection. Give the name.
Okay. Hmm.
Load points. So
Load point.
it has
Hmm.
taken all the 4 points. Okay, we need not to select selectively. Okay, then go
Okay.
to magnitude. Magnitude is your I give z direction, positive z direction. So say
Hmm.
it is 10.
Hmm.
Direction is vector. We change it to component.
Component.
Component, and this will be here. This
My
minus now it will be positive z.
positive now. Hmm.
10. So this is this. That means this 10 we have applied on 4 points. That means
2.5
on
on
each
each.
point it has taken 2.5. Okay.
Yes. Okay.
So total load we have applied. Now you solve it. Now how it has come. It is giving some peculiar behavior. Okay.
Hmm.
Now I have to do it fresh. So
Hmm.
this should come in this side also. Okay, it has not
Hmm.
come.
Hmm.
That
Hmm.
means some fix support. Here.
Fix support on this edge only.
Oh, fix
Hmm.
support is this side. We should
Yes.
apply fix support on that side. Okay.
Yeah. Yeah.
So change the fix support. Fix support I delete. Okay. Now apply the fix support inside. Fix support on this side.
Yeah.
Go to surface
That's,
selection, fix support is here. Apply. Now you solve it. Okay, fix up.
yeah.
What is here? No, now it will come. Solve. Now it has come. Okay.
Yes.
So how to create your points for load? So have you understood it?
Yes. Yes. Sir.
Point. So first you have to select the face on which you
Hmm.
want to create the point. Okay.
Hmm.
Then you select the base edge. From where you
Hmm.
take the dimension. Okay.
Hmm. Hmm.
Then you give the offset value and some other values are there, and these are the number of your points you want to create. Okay.
Hmm.
ठीक है?
Edge offset we have to give from the guide edge.
From the guide edge. And
Hmm.
others are there, that will come.
Hmm.
Okay.
Okay. Okay.
Then next what type of load is there? Huh. Now I have to change the model.
Okay.
So, one more we can show on this model. Moment load.
Okay. Moment load.
Hmm. Moment load we are doing. Okay.
Hmm.
Now delete these points. Now to update the project once I have deleted. Hmm. Let us delete the fixed support. Force, sorry. Delete force. Okay.
Okay.
Now fixed support is here.
Hmm.
We give a moment load.
Okay.
Insert
Moment.
or remote force bearing moment. Moment. Geometry.
Hmm.
We can select the your
Face or edge.
surface.
Hmm.
No, let us select a point. Let us select a point. On this point, we will give moment. Apply. On vertex. Defined by
Component.
component. Say I give x component. X. Newton millimeter. So I give three, whatever value you give. Okay.
Hmm.
Now, you see, it will rotate in this direction. So I give minus
Hmm.
3.
Hmm.
I change the direction. Now it will rotate in this direction.
Hmm.
So this point it will rotate, this point, this moment will try to rotate in this direction. Okay.
Hmm.
So
In the
it will give a
clockwise
twist.
direction.
It will give a twist. Huh?
Hmm.
Solve. show message. Some message just given. One or more remote boundary conditions have been scoped to a solid vertex. Steep beams has been employed to connect the remote point to the vertex. Check results carefully. You may visualize the created beams on solution information folder. Okay. Now let us see the deformation. So it is created like this. Okay. So it is. So as I told you, we never give some your load on a vertex. So stress concentration has come over here. Okay. You see, stress concentration has come over here.
Okay.
So we could have given your moment on this edge also. Okay.
Okay.
Let us give the moment on the edge. Delete. Again, go to moment. Set moment. Select the edge. This edge I is selecting. Okay. Apply. So I will rotate in X direction again. Component. X direction. So again I give the same value, say minus or now try to solve it. Solve. I have not noticed the arrow. So now warning has not come. Okay. So never give any load on a single point. Okay. You have to distribute. Otherwise, this type of error stress concentration will come. Is it okay?
Okay. Okay.
Now. Now what load I show? Insert pressure, rotational velocity, hydrostatic pressure, mode force, bearing line pressure, now all are special loads. Okay. Now one minute. The easier one I will show first.
Okay.
Now go to hydrostatic pressure. So I am going here. Okay.
Okay.
Hydrostatic pressure, that means some your log gate type. You can assume a log gate. Okay. Force is coming on a log gate. Your water level is up to some height. At the top height, your force will be 0.
Yes.
At the bottom, force will gradually increase. Okay, so
Increase.
load is in form of a triangular load. Okay. At the bottom,
Variable.
gradually it is decreasing, and at the top level of the water, force is 0. Can you imagine that?
Yes. Yes, sir.
So applies a linearly varying load to a surface, solid or shell. Okay, the load can be on solid or it can be a surface. Okay. Simulate a fluid force acting on the structure. Fluid may be constrained or external. What is constraint? Constraint means, say your tank. So the fluid is constrained from all the 4 sides. Okay. Or if it is a cylindrical, it is constrained in from all the sides. Okay. That means fluid is completely inside a container.
Yes.
Or external means, as I told you, is a type of block gate. Okay.
Hmm. Hmm.
Now let us take out an example. Let us create a model first in the design model. I am creating a simple model. Okay.
Okay.
I am showing the external only. Yeah.
Hmm. Hmm.
While process mechanical.
Sir, in this flat plate, I have a query that if we wish to give a UDL, means uniformly distributed load, so how can I do this from there?
Uniformly
By,
distributed load is a force.
yeah, force in a surface.
Force now. Force on a surface. You give a force on a surface,
Hmm.
so it will be distributed on the area.
Okay.
Evenly it will be distributed. Okay. Or you give a
And
pressure, it will be distributed on the surface.
surface. And for giving the varying load, so
One
we
minute,
have
one minute.
to. Okay.
Vehicle horn was there, huh? You can say
So for uniformly varying load, so for that we have to give the hydrostatic pressure.
hydrostatic pressure. Okay. Hmm.
Okay. Okay.
Or no. Okay. Now hydrostatic pressure. File new. I am going to file new. Do you want to save it? No. Start mechanical design. Static structure. I go. Hmm. No. Geometry. New geometry. Hmm. Sketching. Unit. Millimeter. Millimeter. Okay. Millimeter is okay. Now go to rectangle. Give the dimension. So this is, let us take V 3000 millimeter. Okay. And this is your, say, this also to the square. Let us take a square plate. Okay.
Okay.
This is this. Yeah. Now, concept, surface from sketch. This, yeah. Concept, surface from sketches. Sketch one. Yeah. So it has created a surface. Okay. Now go to this. Go to model. Now question mark is there, okay, in the geometry. So by surface body, you have to give the thickness. Say thickness is 100 millimeter, okay. It is too thick, so I give 50 millimeter. No mesh, yard mesh. So it has created a your lock gate, okay.
Okay, sir. Sir, instead of doing the extrude command using the extrude command in the design modeler, we are giving this value of here.
We have not created a solid
Okay, okay.
because if we create a now how many elements it has created. Let us go to statistics.
Yeah.
Element it has created 81, a nodes 81, element 64. So if you
Okay.
count 1, 2, 3, 4 like this, then it is 64.
Okay.
If I if I make a solid,
Mm-hmm.
it will be 64 into 64, 64 into 2. This side also there will be the mesh.
Okay. Okay.
Okay. Then in
Mm,
between mesh will be there. Mesh can
mm,
it can be divided. Okay. In between some
okay.
mesh will be generated.
Mm-hmm.
So many elements will be generated and so many nodes will be generated. So if we want to create a model in surface
Mm,
to simulate a solid, then we will prefer
mm.
that. Okay.
Okay, sir.
Always use a surface model if you can simulate it as a
Mm,
solid.
okay, sir.
Okay.
Mm,
Now surface model thickness. Thickness I change it. Okay. So make it 100. Yeah. So like this. Okay. Now it's okay. Now let us fix the top and bottom. Okay. Coordinate
mm,
system is here. Coordinate system is here. So this is the z direction. This is y. This is x. Now
mm,
fix. Insert fixed support. Fixed support.
mm.
Select. Go to line selection. This and this.
Mm. Okay. Both ends are fixed.
Hmm.
Okay.
Oh, I have not selected the control. So this is this and this
Mm.
is this.
Yeah.
Okay. I can select
Mm.
this also. Okay. Fix all the
Okay.
four edges.
Mm.
Apply. So four edges it has selected.
Okay.
Okay. Now go to hydrostatic pressure. Now insert. কোথায় গেল? Hydrostatic pressure.
Hydrostatic pressure.
Okay.
Yeah.
Now what are the inputs required here? Geometry.
Mm.
First select the geometry.
Mm.
Apply. So geometry it has selected. Okay.
Okay.
Now go to fluid density you have to give.
Yeah.
Say I give approximately say 1,000.
1000 for water. Okay.
Okay. 1,000 kg per millimeter cube. Millimeter square. No, cube, sorry.
Mm.
Hmm. Now go to here. Magnitude.
Mm.
Acceleration. Vector is the component. It is component I give. And your jet component. So acceleration is required here. Okay.
Okay.
Jet component say minus 200, 300, 500, whatever it is. Okay. Hmm?
Mm. Mm.
So this is this. So all are satisfied. Now, our free surface location. That means how much water level is there, where water level
Yeah.
is there. Okay.
Mm. Mm.
Y coordinate is say up to 50% of the height water level is there.
Mm.
So y
Mm.
coordinate is 1500. Okay.
Mm.
X is x is three, I take 3,000
3000 my whole area.
whole
Yep.
area. Okay.
Mm. And y is half of the y.
Y is half. Okay, that means water level is half of the gate. Okay,
half of the gate. Yeah.
and jet coordinate is 0. Clear?
Hmm.
Now let us try to solve it. Insert, solve it.
So
Insert, deformation total. Evaluate horizon. It has come like this. Okay. Insert, stress, equivalent, one miss. Let us see how the stress is coming. Your evaluate already. Is it okay?
yeah. So as we have selected the four surface as a fixed point, so the center point
Just
has the
you,
highest div.
you note down. Okay.
Yeah.
Draw this figure in isometric. So this is up to water level is this,
Hmm.
total height is this, total width is this, water level
Hmm.
is up to 1500,
Hmm.
and in this direction it is water level is the whole width of the plate. Okay, and what inputs you record, your density and free water level,
Density and acceleration, water
acceleration,
acceleration,
fluid density, and free level, free surface of the fluid.
free surface of the fluid. Yeah.
So these three are required.
So hydrostatic pressure. Okay, sir.
Then insert hydrostatic force, remote force, remote force.
Hmm. Sir, just for one year, in case of a cylindrical surface, means for a tank,
Hmm.
so we have to consider a cylindrical surface first, and then we have to give the thickness. And instead of fixing the both end, we have to fix the bottom portion only. Am I correct, sir?
Oh, 1 minute. Five close mechanical. One minute. No, one constant geometry type. Then we see whether step file is there.
Mhm.
Concept. No. Now, what was your question? I wanted to show a latest boiler. in case of cylindrical object.
Hmm. Hmm.
Hmm. So surface you have to select all the surface of the cylinder, okay?
Okay, sir. Okay.
And free level is up to which level? Up to the level the fluid is there, okay?
Okay.
It's not necessary that it is the full ekdam, clear?
Hmm.
Some
And in case of there is no acceleration in the tank, so that is a static fluid, so acceleration shall be zero or some
acceleration
value.
is zero, okay?
Okay. Okay.
Or acceleration you can take. Suppose the tanker is going through so it will not the acceleration.
Okay.
Now, if I select acceleration, I have never solved that. If I select acceleration zero, so whether it will solve or not, we have to check.
Yes, sir. So, what I would like to check that means I will do that myself. I try to do that myself, and
You try
I will show you.
and just inform me, okay?
Okay, sir. Okay. Thank
So I was trying to find out a typical geometry like that was there, okay?
you. Means I would like to get the analysis for a vessel. Means
Yeah,
like
yeah, vessel,
yeah,
vessel, okay?
pressure vessel. Yes, sir.
Try that, okay? If it is gets, and
Yes, sir.
then inform me, yeah?
Yes, sir. I will try that, and I will
What it is giving.
show you. Yeah.
Unsupported. Why? Model. Geometry it has not taken. This is geometry. So why it has not opened? It has opened. Okay. Now,
Hmm.
what is remote load? Now, say my interest is on this area.
Hmm.
I will apply load over here and how it is behaving here, what type of stress or deflection,
Hmm.
etc. coming, whether this area is failing or not. That we
Hmm.
will calculate. So you need not to model so many areas. Okay. So what we will do, we will remove all your geometry from here to here. Okay, we'll keep only this portion of the geometry. This portion of the geometry will keep, and load will apply here. This geometry will not be there here, but load will apply here. Okay, and means we'll
Okay.
take out a point over here. How far it is? Okay,
Hmm.
with respect to a project where this point is there, and there we will apply the load at this
Okay.
point. So this point will be connected to this face, the end face
Hmm.
of this one. Okay, that
Hmm.
means your load will be transferred to this face, and
Hmm.
from here it will be transferred to the rest of the area. Okay, so we will remove from here to here, and we will apply a remote load. Remote load means at some remote area we will apply the load at some point where physical solid money your existence is not there. Here only one point we will assume, and on that point we will apply the load. That
Oh,
will be transferred to this surface. Okay.
okay.
So what we do,